Okay, today, so in our previous lecture, we discussed about coding styles and coding guidelines, coding standards, right? So today we talk about something called code review. Okay, so before so what is testing? So testing is a technique um, by which we remove the defects. Okay, but the testing can be carried out only when executable code is released. Okay, I mean you will be you have different test cases and you will run those test cases on the executable code, right? But code review is a technique by which through which you try to remove the defects. Here also, only thing is that you will be able to remove the defects from the source code itself. I mean, it is not from the executable one. Okay, so I mean, you have developed the source code and you have compiled the source code now, and then you going through code review trying to remove defects. That is what the defect. So I mean, you the technique through which you try to remove the defects, but there you need the executable code. That means the code is so the code in executable form is required to test, right? But you can carry out your code review um, on the source code itself. Okay, so review techniques have become very popular, extremely popular, as well as they are cost effective. Code review does not target to detect syntax errors in a module, so but to detect logical, arithmetic and programming errors. That is what we say. So here we try to find the logical errors, right, as well as some algorithmic errors or any programming errors we make, but not the syntax errors. Okay, so syntax errors, as I told you, so you go through a code review to detect the defects as well as you try to remove those defects, right? So that means, so once the code is ready and you have compiled them, right? Once you have compiled them, that means mostly the syntax errors has been removed, right? So by that time you will not have any syntax errors, right? So ultimately code review object to remove the defects. What type of defects? So logical, algorithmic or programming errors. Okay, so eliminating error from code involves testing, debugging and then correcting the errors, right? So how you can eliminate a particular error? So usually first you need to go through some sort of testing, right? Maybe code review or testing through which when you identify that there is a error, now then you try to debug that particular error, and then once once you detect the location where that particular error is, then you try to correct that particular error. This is what we do as part of eliminating error activity. So this is what exactly. So testing is usually carried out to detect if the system fails to work satisfactorily for certain types of inputs and under certain circumstances. Okay, so you give certain types of inputs and then you try to see whether the system fails to those inputs or not. If that is not if the system is not failing to those inputs, then it is satisfactorily working fine. Then I mean there is no problem at all, right? No bugs are there. Then you can conclude, right? So debugging is carried out to locate an error that causing a failure and most laborious and time consuming activity, right? So you may be observed that there are some error. Okay, then what you try to do, you try to debug the code so as to locate where that particular error is. I mean in which particular piece of code that error is. Okay, so then once you identify the error where it is, then you try to correct that particular, right? So usually detection, detecting where that particular or locating an error is a very most laborious and time consuming activity. Okay, and then we have a code inspection. So there also we try to detect the errors directly, thereby saving some significant effort, right? So we will be right. So as part of code review, so there is a concept called code walkthrough. Okay, so it is in a very informal code analysis technique. So here what you try to do is, so a module is taken up for the review after it has been coded and compiled successfully. I told you, right? So then only it is eligible for review. Okay, so once the coding for that piece of module, I mean for the module is done and also been successfully compiled. Okay, so the members of development team are given the code a couple of days before walkthrough meeting. So so what will happen, there will be certain few members, okay, of the development team. So they will be given this piece of code. Okay, maybe a couple of days before the walkthrough meeting, there will be a walkthrough meeting. So prior to that, these members will be given the piece of code, whatever it has been developed so far, right? So each member select some test cases and simulate the execution of the code by hand and note down their findings for discussion in the walkthrough meeting, right? So what they do is, so for each and every, so that's a, let's say, coding for a particular module has been finished, right? And thereafter that code is given to a few members of the development team. Okay, and now what they will do is they will each and every member, they gets they gets few test cases. Okay, so they will be given some few test cases, right? And then they will simulate the execution of code by hand. By hand means you can think of that means they will be they will have certain test cases, and for each of the test cases they try to see the code line by line. That means, okay, so you can think of like you have a piece of programming code, right, on a paper, and then you can take the pen and you exactly go line by line, you check. That is what exactly we say execution of the code by hand. Okay, that means it is not getting executed by the system or by the compilers, right? So it is what exactly done by the developer only. That means you are going through and checking the code. Okay, so the team member is going and executing the code by hand. Okay, and then whatever the findings the team member finds, so those things will be noted down. And so like as I told you, there are few members, so each of them will note down their findings. Okay, and then there will be a walkthrough meeting. So in the walkthrough meeting, these findings will be discussed. That is what we try to do. So several guidelines have been evolved for these things, right? It is all based upon the personal experience, common sense, and several other subjective factors, right? So now these guidelines can be considered as some examples, right? So as part of these guidelines can be something like this. So you should always the code walkthrough meeting, or the members who will carry out this code walkthrough. So actually the number of members should always between 3 to 7. It should not have very few, or it should not have many more. Okay, members. So only 3 to 7 members will be there in the code walkthrough. Okay, so discussion should focus on discovery of errors, avoid on how to fix discovered errors, right? So here, because I told you, so everyone has taken their own test cases, right? For those test cases, they go by they try to execute the code by hand. Okay, and then if at all they have any findings, that means if they find any errors are there, so those errors will be discussed here only. I mean those things, no, main objective of this code walkthrough is to discovery of errors, I mean finding of errors only, but we are not going to discuss here how to fix those discovered errors. Okay, okay, managers should not attend the walkthrough meetings, otherwise coders feel that they are being watched and evaluated, right? So usually when code walkthrough meetings will be conducted, so as part of code walkthrough meetings, so usually managers will not take part. Why? Because you see, so here we are trying to find out what errors, right? So if the manager is there, and if the manager feel that the coder, himself, he coded the program, and he found 10 errors in the code, that means the coder will feel, maybe it is my deficiency. Okay, I mean, I haven't able to produce a good quality code, because I haven't carefully done these things. As a result, there are so many errors. So they feel like this. Okay, so this is the reason why. So managers will be avoided. Okay, avoid the meeting, right? So as a result, what will happen? So the developers, they will be very feel free to detect the errors whatever they made during the coding. Okay, so this is there are certain guidelines for the code through, right? Now we have another one is a code inspection. Okay, as I told you, so previous to previous slide, right? So here, here also we try to check whether the coding standards have been adhered to or not. Okay, that means I told you coding standards should be followed, right? So here during part of code inspection, so mainly the objective of this to check whether the coding standards have been adhered or not. So certainly some common types of errors which can which the programmers may, uh, made, right, because of their oversight, or sometimes their mistake as a mistake. So they during they make some mistakes. Okay, or sometimes some programmers oversights, right? So as a result, there will be some common errors. So those things will be identified. Okay. Now, so there is a beneficial side of this code inspection, right? Because we are trying to get, we receive the feedbacks on the programming style. Because once you have written some code, and it is into the code inspection phase, where the people try to find out, the mistakes, as well as whether you have, if you are not following the coding standards or the guidelines. So in that case, you will be getting feedbacks. That means it is the way by which the programmers can improve their skills. That is what the beneficial side of this. Okay. So other participants gain by being exposed to another programmer's errors, right? So that means, yes, we also learn by the mistakes made by other programmers, right? So what sort of program they are doing, right? So now there are common type of errors that can be detected during this code inspection. We can take an example here, right? What you are trying to do here is, you can think of, you developed a procedure or a function which modifies the formal parameter. Like, so if you developed a function which modifies the formal parameter, that means you created a function which that it takes certain number of arguments, right? So why you have written a procedure? Because your assumption is that, so that particular procedure will take different values at different times, right? So a procedure with different values will be called, right? So that is the reason why we have written a formal parameter way, right? Procedure that modifies a formal parameter. But what we are trying to do is we call that particular procedure or the function with a constant actual parameter. That means you never change those values, right? So let's say you wrote a function which can calculate two integer numbers, right? Some int x comma int y. Okay, but what that means, you have written this particular function, right? So objective of this particular function is what? So whenever you pass two integer values, it should return you the summation of those two integer values, right? But you calling that particular function always with a constant value. Let's say sum of some function, within that you call that particular sum function by two formal parameters, constant actual parameters, right? 2 comma 3, let's say, and you are not changing this sum of 2 comma 3, you are not changing into 4 5 6 7 or 7 8 some values, right? So that means what, we are not actually reaching the purpose, right? So that means we are making this mistake here, right? So we call that particular function with a constant actual parameter, but our assumption is that we wrote a program or the procedure which is actually going to modify the formal parameter, right? So but it is not happening, right? So these things only happens because of programmers oversight or the mistakes, okay? So right, so these things can be easily these things can be easily identified by going by inspecting the code, okay? So they do not require hand simulation, okay? One can understand, right? So when somebody going into this inspecting the code, you can easily identify that is what exactly called as code inspection, okay? But as part of code walkthrough, so we try to go by hand simulation. That means we run the program by hand, okay? So adherence to coding standard is also checked here. So it is also done as similar to that. So now there are certainly common errors that we make during the code inspection. So right, so we try to find see these all, right? So use of uninitialized variables, right? So you have not initialized the variables, but you use that particular variable, okay? So then what will happen, sometimes maybe you will undefined variable, this sort of errors that you're going to see, okay? So now the something like non-terminating loops, so you never terminated a loop, okay? So that means you might have an infinite loop, okay? So that is also one error, right? So you have written the code in such a way that the loop is never terminating, right? So maybe you jumps into loops, right? So mostly you will be to some and you never coming out of it, okay? So incompatible assignments, right? So left side the variable you declared is a integer, now right side you assigning the float value. What will happen? So sometimes incompatible assignments, right? Array indices out of bounds, right? So you have declared array, so whose maximum index is, let's say, a of 10, but you trying to assign a value with the index a of 12, okay? So what will happen? So because you have not allocated a memory for the array, so as a result it will give you an array index out of bounds, right? So similarly you can have many mismatch between actual and formal parameter. That is what I said you, right? So you have a formal parameters like let's say sum of int x int y, but you giving what double values. Let's say you passing 2.0, 3.57, you are passing these things sum of. So what will happen? So usually so there is a mismatch, okay? So like there are these sort of problems. So those things can be detected through the code inspection, okay? So these are the usually errors, we try to detect them through code inspection. Any doubts of our students regarding code walkthrough and code inspection?
Hello, sir.
Yes.
That the meeting you were talking about in this context, isn't that similar to the stand-up meetings we have in Agile model?
Yes, you can think of, right? So here is also, I mean, part of code walkthrough means, so there will be 3 to 7 members, right? They will be assigned this task, okay? So what they will do is, so they will be given the piece of code which is which is required to be that need to be gone through this code review. So then so those people will go through the code, and then they go by hand simulation, they've been given some test cases, right? And then they try to find the errors, right? If at all any errors are there, they will be noting down them, right? And then there will be a code work process, I mean there will be a meeting So in that particular meeting, they will be discussing that yes, I detected this error. So somebody will also discuss that, right? Let's say two persons have similar sort of detection, right? So then you conclude ki yes, that's actually an error, right? So this is only a meeting being conducted to find the errors, not to discuss about how these errors can be fixed up, right? Is it clear?
Yes, sir.
Okay. So now we'll talk about the testing part. So now onwards we start. I know we'll talk about testing. So coding part is almost done, right? So aim of program testing is to help realize, identify all defects in a program. So why you will try to test the software? Because you wanted to identify or realize what sort of what are different defects that are there in a particular program or a software, right? So after satisfactory completion of the testing phase, not possible to guarantee that a program is error free. Okay, so even if we tested the software completely according to the testing team, still there is a possibility of certain number of errors. Okay, so the reason here is the input data domain of most of the large software programs or the softwares is very large. Okay, so because input data is very large, so you can think of one thing like this. Okay, sometimes not possible to test the program exhaustively with respect to each value that the input can assume. Okay, because you see, so it is all like you have created a function, right? So and there is an input domain, right? Input domain means there is a range of data that will be given as an input to the function, right? Now is it possible for test all of the input data? Sometimes it will take millions of years. We cannot test for all of the data for a large function. Okay, or maybe you can think of something like taking a floating point numbers as an argument. Okay, so if you are taking a floating point number as an argument, now you can think of, right? So you can give any floating point number as an input, right? Let's say you say some maybe a particular function will take float x. Float x means it can take any float number, right? So now in the world we have millions of you can have you can think as many as large number of floating number that you can. Okay, so if you think of those things, then you cannot test, right? So if you take all these floating point numbers, probably you will take millions of years, even you cannot test for all of the floating point numbers. So there is an example like this. Okay, so you can think of like each input data takes 1 second to type in. Let's say for each input data, if you take 1 second, now what will happen? Now you can understand for millions of inputs, so millions of seconds you really require to type. And apart from typing, maybe to run that particular code also it will take some time, right? And then by seeing whether the expected output you are getting or not, so that will also take some time, right? So you can think of, right? So it is quite difficult. We cannot take all of the domain data input, but instead we will come up with some careful test cases, right? So careful testing can expose a large percentage of defects existing in a program, therefore provides a practical way of reducing defects in the system. So, if we can test the system very carefully, probably we'll be able to reduce the number of defects. Okay. So as a result, maybe the quality of the system will improve over time, as well as, the cost of the development may also go little less. Okay, so there are certainly some basic concepts part of this testing. We'll talk about each of the terminologies because they will be used throughout the next few lectures also, right? So before that you should be able to know all these the terminologies. Okay, so testing a program involves executing the program with a set of test inputs. Okay, so you will be giving some, let's say you think of something like this. So you have developed a quick sort program, and that quick sort program takes how many numbers? It may take 10 numbers. Let's say input data is 10 numbers, 10 integer numbers, right? Now, so one input set will be the 10 randomly chosen 10 input numbers. Okay, randomly chosen 10 input numbers will be given to the quick sort function that you developed, right? So maybe you will give, maybe the first case you will try is, so you will randomly pick some 10 numbers within the range, maybe 1 to 10. So and then you try to the 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 numbers in a ascending order or not. Okay, so if for a particular input set, okay, for 10 input numbers, if the sorting algorithm is not giving you the sorted values, the values in a sorted order as a result, then what will happen? That means there is a some error. Okay, so this is what you need to try to do. But what we try to do here is, instead of giving all permutations and combination of those 10 numbers, 10 inputs, so instead of that, we find some representative test cases. Okay, so those test cases will, those test cases will have common characteristics with certain number of permutations, right? Now you can think of something like this. So what I can do, one input I can give you here is, first you give all the, maybe all of these input as the same number. Okay, either you give all of them as a 1 1 1 1, all 10 numbers, or if you give all 10 all 10, all the input as a 10 10 10 or 5 5 5. Now you need to see whether what the sorting algorithm is giving you output, right? So either you give all of the input as a 1 or 2 or 3 or 5 4 5 6 7 8 10. So you need to pick only one. Okay, not all of them. Okay, you pick only one. Either you pick all the input as 1, or all the input as 10, or all the input as 5. So you pick any one case that will represent all these 10 cases. Okay, so like this. So you will be taking out one input set, right? The other input set can be a ascending order. So you give the input as an ascending order only. Okay, or that means increasing order. The input as a increasing order. So now there are many permutations, combinations you will get, right? Because you see, 1 2 3 4 5 6 7 8 9 10, this is one ascending order. The other may be something like this, maybe 1 2 3, maybe 7, uske baad maybe 5 or something. I'm telling you here, in this case ascending order only once you will get, but maybe you can, if the repetition is allowed, then maybe you will get some different orders, right? So now you can, you need to take some representative test cases. Okay, the input sets, right? So now you need to select the input sets in such a way that, so they will be acting as a representative for all the input domain. That is what the idea. Okay, so input data and condition under which it fails are noted down, and for later debugging and error correction, right? Once, if whatever the input you have given to the function, and if you if for those conditions, if let's say the system fails, and you will be noting down them, and after that you will be debugging. You will go through debugging process. I mean, to try to locate the where the error is, and then you will try to correct those errors, right? So here is one, the other, these are the terminologies actually, given by IEEE standards, right? So there is a mistake. So mistake is actually the, it is essentially the programmer's action. Okay, so as a result, so mistake is essentially any programmer action, right? That later shows up as an incorrect result. So you made some mistake, as a result the program is going to give you some incorrect result, right? Now whatever error is actually the result of the mistake, right? So you programmer makes some mistake, as a result, so there is some error. Okay, that means you are not getting the correct result as expected, right? As a result, that is what we say is the error, right? So example can be call made to a wrong function. Okay, so you calling you wrote a program as part of, so your call made to a very wrong function. Okay, so that is one example. Okay, now so here error, fault, bug, defect. So these are all the terms or the synonyms. They can be considered synonyms in the area of program testing. That means almost they are the same. Okay, when you say error, fault, bug, and defect. Okay, these are the four words. But mistake is something. So it's a programmer action, right? You made mistake. You oversight something. As a result, there is a mistake happen in the code. Uh, as a result, some error is the output. Okay, so erroneous output you have seen. Now what is a failure? Now how you can define a failure? Failure of a program is essentially denotes an incorrect behavior exhibited by the program during its execution. So failure is not an error. Okay, failure is something, it is giving you incorrect behavior. Okay, so that means whatever the behavior that you wanted to see from that particular function, we are not going and seeing that function. That means the incorrect behavior for the quicksort is what? So the value should, whatever the input that you have given to a sort function, the sort function should give the result to you in the numbers in the ascending order, right? But it is giving you in descending order, let's say. Okay, that means it is showing some incorrect behavior. Okay, but error is something that is came as a that came after a programmer made some mistake. Okay, that is what. So every failure is caused by some bugs present in the program. Okay, so I mean some ways in which a program can fail, and they randomly selected example. Let's say you can think of something like this. Okay, these are the example. So result computed by a program is 0. Okay, then but when the correct result is 10. Okay, so what I'm trying to say, so when you can say it's a failure, so the result should come as 10, but it is giving you 0. Okay, so that is what one failure. The program crashes on an input. Let's say when you given an input to the program, so your program crashes. Okay, that means it does nothing. Okay, so then so that is also one example of a failure. The another failure can be a robot fails to avoid an obstacle and collides with it. Okay, you have written the code in such a way that sometimes even if obstacle is there before the robot, now the robot actually fails to avoid that object. As a result, it go and collides with that particular object. Okay, so now I mean these are the actually failures. Okay, they are not the errors. Okay, errors are something that you made some mistakes. Okay, now you can see here something like this. So how these things, so is it that every error, if there is a error present in the code, that may or may not cause any failure. Okay, if a error present in a program, then that may or may not cause any failure. Now here is the example, best example, right? So now you can see here, let's say for example, we assume that role variable role. So if the role value is always given as a positive, value, never we have entered a negative or 0. In that case, what will happen when you give always positive number? So let's say you have given 1, so that means mark list of 1 is equal to mark. That's not a problem, right? But now if you, let's say if you give a negative value, role as a negative value. Okay, if you have entered a negative value role, so -3, what will happen? Now you will be coming to the else part. Okay, so now mark list of -3, is it correct? mark list of -3, is it correct in arrays? Because you have declared the array size as 1 to 10. That means, so here is the error. Okay, here is the error. If you pass any negative value to the roll, so there is a error, right? But now you see, so what is happening? So your else part contains an error, but your true part does not contain. It doesn't have any error, right? Now you have entered the value always in such a way that you have a positive value. As a result, what will happen? Still there is an error, but this error is not detected. Okay, that means, so what I say, if even if the program contains some error, even if the program contains some error, sometimes it may cause any failure or may not cause any failure. Okay, so that is what the example, right? Is it clear?
Yes, sir.
Yes, sir.
Okay. So that means, so you have to keep the test cases in such a way that test case means what? You have to pick the input values in such a way that, so it should cover all of the branches, right? So you should take one positive value as well as you should take one negative value. Then only you will be able to test this program correctly. Okay. So that is the idea. So test case now you probably understand a little bit, right? So taking any one positive number, it's enough. Taking any one negative number or zero is the another test case, right? So these are the two inputs, different inputs that you can try with. It's not really required to give all positive numbers 1 to 10. It is not required. Okay, only one input value with which you can almost detect this error, right? So this is what. So a test case is a triplet. So ISR, where I is the input data to the program under test, S is the state of the program, right? And R is the result expected to be produced, right? I mean, what is that input data you're giving to that particular test function, okay, or the program under test, and S is the state of that particular program, okay, and then R is the result expected. What is the result it is going to give? Okay, expected result. So this is the way that we define a test case. Okay, so test case will be written using a triplet ISR. Okay, now you can think of something like this. Let's say let's say example of a text editor. At any time during its execution, assume following execution modes. Let's say you have a text editor. So the text editor can be in edit state, or it can be in view state, or it can be used to create a test file, or it can be used to display something, right? So if you take any VI editor kind of in Linux, there is a VI editor, right? You can you can think of like that. So it can go into edit mode or view mode or create mode or a display mode, right? Now, so it has its own different states, right? At different point of time, it can be in any one of the state, right? Now, one test case can be written like this. So input will be given as a ABC, and at that particular point of time, the state will be edit, and the result will be ABC. That means what it all says. So the input ABC needs to be applied in the edit mode. The input ABC will be applied in the edit mode, which will result in result in ABC would be displayed. That means the ABC will be displayed. So you have given ABC as an input to the edit mode, and then your edit at that particular edit state, the program is going to, the text editor is going to display the value ABC. Okay, so this is one test case you can think of. This way the test case can be written, right? So it always have input data, state, and the expected output. The expected output there is what? So ABC only, because you inputted ABC into the edit view. So usually you're going to see ABC only, right? So a test scenario is an abstract test case in the sense that it only identifies the aspects of the program that are to be tested, right? So when you say test scenario, so that means it through what you try to do is it all trying to test a particular aspect of the program. Okay, without identifying what input, state and output, right? So when you have a test case, so you will be defining there what is the input, state and output, right? What expected output, right? But here, so when you say test scenario, that means only it says that we are going to test a particular aspect without identifying as of now what is the input, what is the state or what is the expected output. That is what we say scenario. Okay, a test case can be said to be an implementation of a test scenario. Let's say you have a test scenario. For that, you will have certain number of test cases. Okay, when you apply these all test cases, that means you actually implemented. If you develop the test cases for that particular test scenario, that means you are going to implement that particular test scenario. Okay, so for a test scenario, you will have test cases. Okay, for a test scenario, you will have a test case. Okay. A test script, so it is an encoding of test cases as a short program, like so exactly the test cases will be converted into a short program. Okay, why you would do all them? Because you wanted to automatically execute all of the test cases. Let's say you have a thousands of test cases. Okay, so they have been converted, they've been written in a small program, that is what we call as test script. So as part of test script, so you will have the encoded test cases. Okay, and those test cases will be taken up by one and they will be getting executed. Okay, so that is what. So there is a positive test case. Okay, so what is a positive test case? So these test cases are designed to test whether the software correctly performs a required functionality or not. Positive test case means, so the test cases actually designed to see whether the software actually performs correctly for a particular required functionality. Okay, a negative test case is designed to test whether the software includes something that is not required. So negative test cases are usually developed to see and test whether something is included in the software which is really not required. Okay, let's say you can think of something, some examples, right? So one here is, let's say, manager login system. So for a particular system, we have a manager login system. That means the manager is going to log in into the system, right, using a username and password, right? So the positive test case here in this case is validates the user with correct username password. Okay, validates a user with correct username and password, right? So this is the positive test case, right? You wanted to see whenever a person comes with a manager comes with a correct username and password, so the system should validate it. Okay, this is what the functionality, right? It's a functionality that should be there in the system. The negative case is something what, whenever a manager or any person enters into the system, try to enter into the system with wrong login password. That means username and password. When it is entered, then how the system is going to require. Okay, actually, so this is not really required. Okay, I mean, only thing is that we want to validate something, someone. This is a requirement, but this is not required. But whether, so these negative test cases are written something like this: whether someone comes with a wrong username and password, whether the system admits to the whether the system admits that particular user or not. So this is a negative test case. Okay, so negative test cases are also sometimes required. Okay, because you need to ensure that something should not happen. Which is not really, uh, which is also not required. Okay, so something required and something is not required. So everything should be captured through test cases, right? So that is the positive test cases are designed to capture the required part, and negative test cases are going to capture the not required part. Okay, so a test suite usually is a set of all tests that have been designed by a tester to test a given program. So test suite means, as I told you, so it will contain all the tests, okay, or the test cases, okay, that has been designed by a tester to test a particular given program. Okay. Now then, what is a testability? So testability of a requirement denotes the extent to which it is possible to determine whether an implementation conforms to both functionality or performance. Okay. So that means you know, when you say testability of a requirement, it means up to what extent we are possible to say that the whatever the code that has been implemented so far, okay, or that developed so far, whether they meet the required functionality and performance or not. So that will be that. Okay, that is what exactly we call as testability of a requirement. Okay, that means that requirement, whether we will be able to test, whether we will be able to test that particular requirement or not. That is what a testability. We should be able to see that we will be able to test that particular requirement, that they meet functionality as well as performance. Okay, so that is what we say testability of a requirement. Now let's say there are two programs implements the same functionality. Which one is more testable? So now you can understand. Let's say you have given the two programs. Okay, both of the programs going to implement the same functionality, but which one is more testable? If somebody will ask you which one is more testable, the one which will take less number of test cases, the program which is written in a very simple way, that means it is a very less complex program, then only it is more testable, right? A more testable one have a lower structural complexity. That means the decision statements are very less, like if else, control loop. So these are the decision statements, right? So a more testable program will have very few number of decision statements. If it has a few number of, that means what I'm trying to say. So both the programs going to come up with the same program. Let's say I gave the same prime number. So try, I gave is to two students, right, to tell, to test whether a number is a prime or not, right? So to test these things, so there are many ways you can write that particular program. Okay, so now, so maybe one code is less efficient in terms of time complexity. The other one may be best in terms of time complexity. Right now, let's say these are the two program given. So one program uses few number of decision statements, and the other program is implemented using more number of decision statements. That means more number of decision statements means more test cases you really require, because you need to test all of the cases, right? If else part. Okay. So if less number of control statements, that means you will have less number of decision statements, right? So that means the program which will have less number of decision statements will lead to lower number of test cases. As a result, it is better. Now you can see there is a failure mode of a software. Okay, so what is a failure mode of a software? That all failures that have a similar observable symptoms. That means, so when you say it is that particular software is in the same failure mode, because they're going to display similar observable symptoms. Let's say, for example, you can see failing to book an available seat when you are booking, when you are going to book a railway ticket. So right, so you unable to book a available seat, or sometimes it is going to give you incorrect seat booking, or maybe the system is crashing, right? So these are all have similar failure mode, right? Because they all leading to failure, right? System is crashing is a failure. Incorrect seat booking. So you ask for a one seat, but it is giving you another seat. That means what? So here is also failure you have seen. Failing to book an available seat, but it is showing there is a available seat, but it is giving maybe occupied seat. So now you can think of, like, So all of them leading to the failure only. So a failure mode will have similar observable symptoms, right? That means here is similar sort of failure. Okay, so now equivalent faults. So when can you say the two or more bugs they are resulting in the system failing in the same failure mode? Okay, so that means whenever you see the bugs and these bugs have similar characteristics, okay, or I mean that means they are in a same failure mode. Okay, so like you can think of another example here is divide by zero and illegal memory access error. So these are the two equivalent faults because they both leading to the system crash. Okay, that means they are in the same failure mode. You can see. Okay, so system crash is one failure mode, right? So that means divide by zero, that is also going to crash the system. If you have illegal memory access, that is also going to crash the system, right? So that means so two bugs which is going to which will be resulting in the same failure mode. Okay, so then we can say uh, they are equivalent faults. Okay, so here you understand, right? Now there is a concept called verification and validation. So you understand. So both are going to both are usually used to remove the errors in the software. However, the detection techniques and their applicability where they are applied are different. And what detection technique they are, how these detection techniques works, so they are different. Okay, so that is what exactly verification and validation. And probably, and I already discussed about these things. Verification is something is a process of determining whether the output of one phase of the software development conforms to the two of its previous phase, right? So that means let's say you have requirement phase and you have design phase, right? Whatever the output comes from the requirement phase and from the design design phase, so they should comply. That means there is a problem, right? It is within the development phases, right? I mean within the development stages, right? So the testing, right? Validation is what? So determining whether the fully developed software conform to its requirement specification. That means validation stage, I mean validation is the process where you try to see that whether the system that you developed is actually going to meet it all the users requirements or not. Okay, that is what validation. So the validation is carried out at the system testing level, right? Verification and all at the unit testing level, right? Verification step to check if the design documents produced after the design step conform to the requirement specification. That is what I say. Okay, so whatever the requirement specification that we have obtained in the requirement analysis phase, right? Whether that is complying uh, uh, with with the design document or not, that will be checked. But here now validation, when you say, it is all we try to check whether all of the requirements have been met or not. So this is checked. So this is what we call as verification and validation, right? So now there are certain techniques being used for verification. They are the review simulations. Sometimes we go by some formal verification techniques, right? So when you say formal verification, right, you try to use some theorem proving techniques or you use some automated tools, okay, through which you try to verify. And validation techniques primarily based on the product testing. That means final product is being tested, okay. And now these testing is also categorized under both categories like program verification and validation, right? That means we carry out testing at the verification time as well as we do testing at the validation, right? So the testing, that means we try to do unit and integration testing, they will be part of the verification, and system testing will be considered as part of the validation step. We try to see whatever the code we have developed, whether that meets the requirement specification or not. Okay, so I think I can stop now here. Little bit, I quickly go by verification. When you go through this verification, they actually does not require execution of the software because we try to do these verification things from the coding itself, because unit testing and integration testing can be done with the coding itself, right? But when you go for the validation testing, that means you need the execution of that particular software. That means it is carried out during the testing phase, right? Actually, software testing phase, right? So your verification is actually carried out as per the objective of this phase containment of errors, right? Because we try to find the errors where these errors are actually present, right? So that means that is what we already talked about, this phase containment of errors, right? So when you say verification, actually we want to achieve this phase containment of errors, right? That means which will actually going to reduce the number of bugs, okay? As a result, the cost will be reduced. So validation is to check whether the deliverable software is error free or not, whether that is as per current users requirements or not. So whenever you say error detection technique, I mean you are trying to calculate and you are trying to detect these errors or the bugs. So you usually go through these two steps, right? Verification techniques as well as validation technique, okay? Right. So, sometimes we go by validation technique alone, but the cost will increase drastically. Okay. Someone can say, I will not go by verification techniques. I will not go by unit testing. I will not go by integration testing directly. Why not? I can go to the system testing. That is fine. You can do. But for a very highly reliable software, usually you should not go alone. Okay. So you should take both the things, V and V activities, verification as well as validation, both are required really. Okay, so now we'll stop at this point of time. Maybe we'll continue about the other things in the next lecture, right? So any doubts of our students quickly? No doubts.